Hello everyone, this is Rafeel Riaz from the Department of Astronomy, University of Concepcion, and this brief presentation is about the black hole binaries from Pop.III fragmentation in the S2 line cooling phase. A brief context. Laser Interferometer Space Antenna, called LISA, is a gravity probe, and one of the objects that it will be focusing on is the extreme mass ratio in a spiral. The system consists of a massive black hole at the center spinning, and around this massive black hole there is another object which could be a black hole or a neutron star spinning, or rather circulating in the orbit, which could be an inclined one. So the spin of this massive black hole causes the precessional motion in the orbit of the secondary, and that results in a modulated signal, which we will be focusing on with the LISA. So we ran some simulation models based on the primordial gas collapse, and we in fact run 4 models in which we vary the Mach number within the range of subsonic turbulence, and we focused on how many systems are coming into existence in form of single star systems or binary systems. We found that the model which is on the higher side of the subsonic turbulence with Mach number 0.8 has yielded one binary system which is with extreme mass ratio. As I told you that we ran 4 models, so this particular model with Mach number 0.8 has yielded a system which has extreme mass ratio such that the mass of the primary is 126.4 solar masses, and the secondary has 0.8 solar mass. As you can see that the extreme mass ratio is there 0.006. The semi-major axis is 53 astronomical units, and the eccentricity of the orbit is 0.16. We also focus on how the accretion is going on in this extreme mass ratio system. We found that the primary is quite vigorously accreting from the surrounding material. You can see here, this is the development of the mass profile for the primary and the secondary. It is this particular system which is the extreme mass ratio. Otherwise, there are other binary systems as well with respect to the other simulation models that we followed. So this is the extreme mass ratio case represented in the black and the gray colors. This is the mass accretion rate profiles, and this is the mass accumulation profiles. We also try to focus on the accretion disk for these 2 individual objects constituting the extreme mass ratio system. We found that the disk, both the primary and the secondary companion, has a very stable disk against the gravitational fragmentation. So there is no fragmentation going on. So most likely the system is actually formed by capturing a secondary from the primary. The primary captures the secondary object and forms the binary system. If you see the radial profile, you will find that the extreme radial velocities are also observed for this extreme mass ratio system, which is an indication that a constant inflow is going on for these objects, which means that they're going to accrete further, they're going to grow in mass. But since the radial profile is somewhat close to identical for these primary and the secondary companion, so we expect that the mass ratio is going to be maintained over the course of the system evolving in general. So the conclusion is that H2 line cooling channel in the primordial gas could be a formation channel for this extreme mass ratio in spiral sources, And this is the object that we could be focusing on with Lisa. Thank you very much.